Hello everyone and welcome back. Now, in the previous video, I gave you a sort of crash course on linear systems of ordinary differential equations. In this video, we're going to do a fun application of these linear systems of ordinary differential equations that will hopefully help you sort of visualize and interpret solutions to these things. Now, I told you really what it comes down to is eigenvalues and eigenvectors, right? So what I'm going to do in this video is walk you through a fun application of these linear systems, and we're going to use these solutions, these eigenvalue, eigenvector solutions, to plot out what the system dynamics actually look like. Now, the specific system that we're going to work with comes from a now very famous 1988 paper due to Steven Strogatz, where he was trying to model Romeo and Juliet's love for each other. Okay, so this has become a very standard example now throughout nonlinear and linear dynamical systems. You can find it in Steven Strogatz's textbook as well. And so what I'd like to do is I'd like to walk you through a couple of the cases, and I'm going to leave some of the other cases for you to try and work through on your own. Okay, so here's the basic idea. I'm going to let R of t equal to Romeo's love for Juliet at time t. Now, the basic interpretation here is that if the value is positive, that means that Romeo is feeling love for Juliet. Now, if the value is negative, that's sort of a negative love for Juliet, we're going to interpret that as maybe dislike or hatred, okay? So if this thing is very large and positive, Romeo is really in love with Juliet. If it's very large and negative, Romeo is really feeling a lot of disdain for Juliet. Well, we can do the same thing. Let's let J of t equal to Juliet's love for Romeo at time t. I forgot to put the t on the top one at time t. Okay, so this is a dynamic system. It's changing in time. They're going to be reacting to stimuli from each one of them. And the way that we're going to model this is we're going to model this with the following system, okay? So that the rate of change of Romeo's love for Juliet at time t is going to depend on what Romeo is currently feeling, some multiple of that, and we'll explain the multiples in a second, plus how Juliet is also feeling. Similarly, Juliet will respond, her love will respond as how Romeo is currently feeling, plus how she is currently feeling. Now you can go back and check your notes and you can see that this is aligning with our linear system, right? The biggest exponents on the state variables are R and J, and we have just multiplications by linear, A, B, C, and D, which are just real numbers. Now, for this example, actually the exact values of A, B, C, and D don't really matter. So we're going to sort of look at large classes of what A, B, and C could be and what this actually means. But it's worth sort of maybe stopping here for a second and thinking about what's going to happen. Okay, so if we have the rate of change of Romeo's love for Juliet at time t is proportional to the sum of two pieces here, okay? So let's look at A times R. If Romeo is feeling a lot of love for Juliet, so R is positive, then he is going to be influencing his own love for Juliet, the change in it, according to this value of A. Now, if A is positive, that means that Romeo is feeling enthused by his own feelings, right? He's in love and he's sort of driving himself to be more in love with Juliet. But if A is negative, maybe he gets a little down on himself. Maybe he says, I shouldn't come on so strong, right? Maybe I should tone it down a little bit. And it says that when Romeo is very in love, he feels the need to sort of regulate himself. The same thing happens here with Romeo's response to how Juliet feels. If Juliet is very, very positive, then if B is positive, Romeo's reacting to that. He says, oh, she really likes me. I really like her too. But if B is negative, then Romeo is saying, okay, well, she really likes me, but I gotta cool it, right? She's coming on way too strong. I gotta step back for a second. Okay? So the same basic principle is at play for both Romeo and Juliet. They have a response to stimuli from each one of them, and it's going to depend on whether or not these A, B, and C and D values are actually positive or negative. Now, we can actually break down a couple cases here. I'm just going to do it for Romeo. Everything will carry over for Juliet as well. So the first case is called the eager beaver case. So, in the eager beaver case, both A and B are positive. So that means that Romeo gets very excited by his own feelings for Juliet, and he gets excited for Juliet's feelings for him as well, right? So if Juliet is very in love with him, then B times J is going to be very positive, and Romeo is going to want to increase his love for her. He gets very excited by both himself and Juliet's feelings. Well, then there's the narcissistic nerd. Again, these are Strogatz's words for all of these. You know, I didn't come up with eager beaver or narcissistic nerd, but they are good descriptions of what's going on. So this is when A is greater than 0, but when B is less than 0. So this says Romeo gets excited by his own feelings, right? He's a narcissist. He goes, I feel good about her. It's gonna make me feel better. But when Juliet starts to feel good about him, he starts to sort of cool off a little bit, right? He says, she's coming on a little strong. Maybe she can tone it down a little bit. And maybe I gotta back off. Okay, so here's another one. A cautious or secure, sometimes people refer to this as the cautious lover. Okay, so this is when A is less than 0 and B is greater than 0. It means that if Romeo is feeling a little too excited about himself for Juliet, he says, I gotta cool it off, right? Maybe I'm gonna scare her off. Maybe I'm coming on a little too strong. I'm acting a little weird. I gotta settle down. Whereas if Juliet gets excited about him, then he says, oh, this is great. She cares about me, right? So that's what's happening in this example. And the last one here is the hermit. And that's when both A and B are less than 0. That means that Romeo is responding negatively both by his own feelings and from feelings from Juliet. Right? He's just like, why am I feeling this way? I'm a robot. I should not be feeling feelings for everyone. I gotta cool off. And that is exactly what's happening right here. So you can transpose exactly the same ideas onto Juliet just by replacing A and B with C and D. And so what that means is that you have 4 choices for Romeo's way of approaching this, and you have 4 choices for how Juliet approaches this. Okay, so there's a lot of different cases that you can look at here, and so I would like to just work through, a couple of these just to sort of show you what's going on. Okay, so here's what I want to do. I want to start with the first one, which we're going to call fire and ice. So fire and ice. So they are opposites of each other. Now, what does this mean to be fire and ice? It means that C is equal to minus B and A is equal to minus D. Okay, so what this means, A and D are their own responses to their own feelings. So this says that Romeo's response to himself is exactly the opposite to how Juliet will respond to herself. So if Romeo responds positively to himself, Juliet responds negatively to herself. Similarly, B and C are how they respond to each other. If Romeo is responding positively to Juliet, then Juliet is responding negatively to Romeo. They are acting in exactly the opposite ways to each other, all just coming from this notation right here. And so if I use the A matrix that I talked about in the last lecture for how I represent the right-hand side of this thing, this would be A times B minus A. Okay, so nothing too fancy. But we saw in the last video that everything comes down to finding the eigenvalues of this matrix, right? So in this case, you can do a really nice, simple symbolic computation. You could use Mathematica or Wolfram Alpha or Maple or even MATLAB will do this for you. So all kinds of different ways. You can see that the eigenvalues are given by, I'm going to call them lambda 1 and lambda 2. They are plus or minus the square root of a squared minus b squared. Okay, so that means that we have to look at two possible cases. One case where underneath the square root is positive, and one case where underneath the square root is negative. So let's start with case 1. So case 1 gives me, let's say, a is larger than b, an absolute value, right? These could be positive or negative values. But because we're squaring them, this means that my eigenvalues are real. So this tells me that, say, minus the square root of a squared minus b squared is less than 0, which is less than a squared minus b squared. So they're just two real eigenvalues. Now the last thing, or one thing that you might remember from the previous video, is that really sort of what happens as time goes on is really sort of dependent on if these are positive or negative eigenvalues. We saw that negative eigenvalues lead to exponential contraction, right? E to the minus t, and it goes into 0. Whereas positive eigenvalues lead to exponential expansion, e to the t, right? You sort of grow as time goes on. So in this case, you would get a solution. So your solution to your differential equation, it would be Romeo at time t, Juliet at time t. And this would be, so a constant, C1 times V1, E, and then your first eigenvalue, let's put the positive one first, a squared minus b squared, t, plus C2 V2, e to the minus square root of a squared minus b squared, t. So how did I get that? Okay, well, there's my one eigenvalue. There's my other eigenvalue. I didn't actually compute what the eigenvectors are. You're more than welcome to. It's not a very difficult process, but they are right there. So the V1 is the eigenvalue corresponding to the positive eigenvalue. V2 is the eigenvector corresponding to the negative eigenvalue. And each one of these in isolation corresponds to one of those solutions that I talked about in the previous video. C1 and C2 are how you put these two things together. So it's just like a linear combination in linear algebra, right? In fact, this is exactly, you're saying the solution is in the span of the two solutions you found using eigenvalues. C1 and C2 could be determined, or would be determined, by whatever your initial state is, right? So maybe Romeo is really in love with Juliet initially, but Juliet really doesn't like Romeo initially. So this would be a positive and a negative initial condition. Then you could use those to pin down C1 and C2. Okay, so what would solutions to this thing look like? Well, they come in two different flavors, okay? So the first one is going to be when you have A and B positive, okay? So if A and B are both positive, you get the eager beaver for Romeo, right? And that would mean that Juliet is falling into the lover category due to these negative signs. Okay, so let's look at this. Let's say, so Romeo equals to eager beaver. Juliet is equal to the hermit. This tells you that A is bigger, A is bigger than B, which is bigger than 0. All right, eager beaver is when both of them are positive. When both of them are positive, I disappear these two absolute values. And the hermit comes from the fact that Juliet is adhering to the negative of what Romeo is doing here. Okay, so let's sketch out what solutions to this thing would look like. Okay, so I've got Romeo, I've got Juliet. Now, in this case, my eigenvalues, so if you go through and you compute your eigenvalue, or your eigenvectors, pardon me, you're going to find that you are moving in this direction. So I'm going diagonally here for my V1 eigenvalue, or vector, and V2 is moving in this direction like this. So let me sketch out what some of these solutions are. You can put in some different values of C1 and C2. Maybe you want to use some exact values of A and B. But let me just show you what happens here. Basically, this is what you're going to get. So these are, the arrows indicate motion with respect to time, just like we did with the phase plane diagrams. And similarly, you might get something. So these are just meant to be sketches, right? I don't know exactly what the values of A1 and B1 are, or sorry, A and B are, but that does not really matter to me. And then I get something that would go like this. Maybe it will come in like this. You know, these aren't meant to be perfect art projects, but it's just to give you the general feel of what's going on here, okay? So, okay, so all that those come from is knowing the general motion of each one of these eigenvalues, or the general direction of each one of these eigenvectors, and which direction you're contracting in and which direction you are expanding in, right? So you can see that you have sort of contraction coming along this direction, you have expansion coming along this direction, right? So V1 is running in this direction. That comes from the fact that everybody is following V1 as time goes to infinity, right? You're sort of stretching along this direction, because as time gets large, this piece disappears. You're only left with that. Similarly, V2 is coming along this direction. This is the piece that's getting pinched as time goes on. Okay, so how do I read that picture? What do I see out of this thing? Well, the first thing that I see is that everything is sort of going up in this direction or down in this direction. So if I'm going up in this direction, what happens? Romeo is becoming negative, Juliet is becoming positive. So that means as time goes on, Juliet is falling more in love with Romeo because she's positive. But as Juliet gets really in love with Romeo, Romeo is not having it. And he's saying, you know, I'm not interested in Juliet. Similarly, over here, Romeo is getting really, really in love with Juliet because he's going to the right. He's getting positive. But Juliet is negative and saying, you know what? I'm not into it. This is exactly the fire and ice scenario, right? They are completely opposites. They react to each other in completely opposite ways. You know, as one falls more in love with the other, it drives the other one away. Now, this is going to be the case for every one of these solutions. So if you want to, you can sort of sketch this out for yourself, and you can see that everybody's either going to the top left or to the bottom right. And in these quadrants, this is where you have one loving you and one hating you. That's what's happening, or one hating the other. Now, if you wanted to look at the other case, where you have, so the other case where you can satisfy this is when you have a narcissistic nerd. So one A is positive and B is negative, and then that would lead you to a cautious lover for the other one. The only thing that that's going to do is it's going to take this whole diagram and turn it this way. Okay, so let me actually write it out for you just so we can see it, and I'll do a little sketch just so that you understand what I'm saying. So let's say narcissistic nerd. And Juliet is a cautious lover in this case, right? So if A is positive, that means that D is negative. If B is positive, that means C is negative. So in this case, she would be a cautious lover. So in this case, you're going to get that A is bigger than 0, which is bigger than B, and A is bigger than B in absolute value, right? That was the first piece that I assumed right here for case 1. The second piece comes from the narcissistic nerd. So if I was to sketch out solutions to this thing, oh, sorry, this should be Romeo. Romeo and Juliet. In this case, what you see, again, it's basically a mirroring of what was happening over here. So you get something that looks like this. And so bear with me for some sketching here for a second. And maybe you get something that comes up like this. This should be going directly up. Again, you know, it's not an art class. It's about interpreting these pictures and figuring out how to describe something that you're seeing here, right? Okay, so what is it that I'm seeing? I am seeing that these ones, they go into the first quadrant. They, you know, as time goes on, they remain in the first quadrant. Why is the first quadrant interesting? That's where Romeo and Juliet love each other. Both of them feel strong affection for each other. Similarly, down here, you see that you sort of go down into the bottom left corner. You go into this third quadrant where both Romeo and Juliet are negative, meaning they both hate each other. Now, what does this tell me? It tells me first impressions matter. If Romeo and Juliet initially like each other, well, then they're going to get taken on a ride and they're going to fall madly in love and go crazy, and they're going to just continue to love each other. But if initially Romeo and Juliet don't like each other, they're going to just continue to not like each other. Similarly, if you put yourself in one of these quadrants, if you start down here where Romeo initially likes Juliet, but Juliet doesn't like Romeo, right? So Romeo positive, Juliet negative. You're going to ride this, and Romeo's eventually going to win over Juliet, and he's going to make her love him. And they're both going to be in love. Now, if I did the same thing, if Romeo initially doesn't love Juliet, but Juliet really does love Romeo, well, unfortunately, Romeo is going to continue to be turned off, and that's going to turn off Juliet, and they're both not going to like each other. So what this tells me is that, again, first impressions really matter. Initial conditions are your first impressions. How they feel about each other to start is going to determine if they fall in love or not. It's going to tell you if you're on, you know, a trajectory into the first quadrant or a trajectory into the third quadrant. Okay, now let's look at case 2. So case 2 was when the absolute value of A is less than the absolute value of B. This means that Romeo gives more preference to how Juliet feels about him than how he feels about Juliet. And so that means that in this case, the eigenvalues become, they have a negative under the square root. So that means that we get a squared minus b squared, plus or minus. This is plus or minus I, b squared minus a squared, right? And in this case, this becomes actually positive. Okay, so that means that the solutions now are complex oscillations, right? This gives me sines and cosines in my solution. Remember that we saw when you have complex eigenvalues, the real part stays with the exponential, and the imaginary part now goes into the sines and cosines term. All right, so this is really going to give you, sine of the square root of b squared minus a squared times t, and cos of the square root of b squared minus a squared minus times t, right? This is all coming from Euler's formula. And so if you were to actually plot this out, well, there's two cases that this can come from. The first of which, again, is an eager beaver and a hermit case. So eager beaver, which is Romeo, pardon me, and Juliet is a hermit. So it's same two cases that we saw last time, but in this case now I get B is greater than A, which is greater than 0. Right? So it's still the same situation as we saw, but now the values of A and B are flipped. Right? B is larger than A. In this case, here's what you're going to get. So you're going to have to actually compute those eigenvectors, decompose them into real and imaginary parts. But the point is, everything is periodic in time, sines and cosines. That's it. And what that means is that everybody lies on ellipses. And so all of your solutions look like this. All right, so I'm going to spare you my bad drawings here, but this is what everything looks like. And these are closed loops because they're periodic, sines and cosines. There's no exponential growth. There's no exponential contraction. We just go round and around and around in a circle. So what does this mean? Essentially, Romeo and Juliet are sort of trapped in this game of chasing each other around, right? So if you imagine you're on this circle here, maybe you start, initially they both really like each other, but they both feel like maybe things are coming on too strong. And so as Romeo is getting bigger, right, he's falling more in love with Juliet. Juliet's, she's a hermit. She's kind of not responding to it in the same way. She says, oh, this is a little too much. And so she goes down. And so eventually she starts crossing into a hatred of Romeo. She becomes negative. And Romeo starts responding to that. He says, okay, well, if you hate me, what's the point, right? And so Romeo starts to decrease here. But then when Romeo starts going down, Juliet says, oh, wait, I don't want to chase you off. And so then Juliet starts to like him again, but Romeo is in the situation of not liking her. And so you get this perpetual cycle of like two little children almost, this sort of high school drama of chasing each other back and forth. Now there's one other case here, and it's again the narcissistic nerd. And that's for Romeo. And Juliet, in this case, is the cautious lover. And this comes from, in our case, A is bigger than 0, which is bigger than B. So B becomes the negative value. And in this case, if I just sketch up what's happening in this RJ plane, it's basically exactly the same thing. It's just flipped. So the same basic process as what we saw in the previous example. You sort of have this mirroring property. And in this case, we're spinning in this direction. And you get the same basic problem, right? Again, the complex eigenvalues means that everything is periodic. And so they're just going to go around in a circle. They're just chasing each other, right? The more, if I start way up here, well, Juliet and Romeo both feel that they're both coming on a little too strong and they got to dial it back. And they both start to decrease. Romeo starts to dislike Juliet. Juliet doesn't like that and feels disliked. But as Juliet starts to dislike Romeo, he says, well, wait a minute, I don't want to let you go. And you get this sort of perpetual chasing each other in a circle, kind of to no avail, right? You never really get anything out of this. Okay, so there are lots of other situations that you can go through, and I encourage you, try and look at some fun ones. All over the internet are different examples and different names for the different ways that you can set these things up. So for example, here's another one. So we've been looking at fire and ice. Let's look at out of touch with one's feelings. And in this case, this would give A and D equal to 0, right? So Romeo has no response to how he feels. He only cares about how Juliet feels about him. Similarly, Juliet has no response to her feelings. She only cares about how Romeo feels about her. So in this case, you would get a differential equation that looks like this. B times J. Again, Romeo's only responding to Juliet's feelings, and Juliet is only responding to Romeo's feelings. Okay, so it turns out that there are different cases, whether or not B and C are positive, but they turn out to be very, very similar to my fire and ice cases. So what I'm going to do is I'm going to leave that for you to take a look at. Remember, all it comes down to is looking at the eigenvalues of this matrix. So it's going to be 0, B, C, 0. You can work out what the eigenvalues of that matrix are pretty simply, and then you can figure out maybe if they're complex or if they're real and offer up a little sketch. I will sort of ruin the surprise a little bit. It's going to be extremely similar to the cases that I looked at right here. So you go ahead and try that. I'll give you a little bit of practice, and try and make a new scenario. Try and give a name to a scenario by choosing values for A and B, or value ranges, and looking at Romeo and Juliet's response back and forth to each other based on these two things. All right, I'll see you in the next video.